A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology funded by Ministry of Education, Government of India. This lecture will be a part of the module 2 under the lecture 4 on Unbound courses and their functions. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, under the Unbound courses, especially covering the sub-base and the base courses, the major courses which we discussed in the previous lecture also. So, there are 5 different categories under which it can be clubbed up. So, the first one is you have immediately above the subgrade the granular sub-base course. The granular sub-base course, if it is unbound, there is no cementing material in it, then it is an unbound granular sub-base course. Water-bound macadam is also a kind of course which is used as a sub-base course or a base course. Base course is the one which follows the sub-base course in the flexible pavement structure when we go from bottom to up. So, you have the subgrade here. Over the subgrade you construct your sub-base courses, which may be a bound courses or an unbound courses, followed by base courses. Again, base courses can be your bound courses, unbound courses, and then you have your binder courses or wearing courses, which are typically bituminous bound in case of flexible pavements. Now, as I mentioned, the sub-base course can be constructed using some cementitious material, which can be fly ash, which can be cement or any other pozzolanic material or a combination of it, then it becomes cement treated sub-base course. Thereafter, the another common course which is used as a base course and it is unbound in nature, it is our wet mix macadam course. So, it is the wet mix macadam base course which is used. It is an unbound course which is used as a base course. Now, this unbound course, so we discussed about in the previous, we discussed about these 4 courses. Now, if some cementitious agent is used in the base courses, then it will be cement treated base course. So, we will see some features of the cement treated base course. Now, in terms of material composition, it states that the MORTH classification states that, or IRC along with it IRC 37 2018 states that cementitious base layers typically consist of aggregates, reclaimed asphalt material, it is older asphalt pavements, bituminous pavements. If they are scrapped out and that material is used again, we call it as reclaimed asphalt pavement, or abbreviation is RAP. You can use crushed slags. Nowadays, this is an industrial byproduct. Steel industries generate a lot of slag that can be crushed and used in the construction of base courses. Crushed concrete aggregates, if there are some building construction waste are there, so those aggregates can be crushed down and used in a cementitious your cement bounded base courses, or soil aggregate mixture stabilized with chemical stabilizers. This is the important aspect. We need to look what kind of stabilizing additives can be used. So, as I mentioned, any material which have some pozzolanic characteristics or like cement, lime, fly ash or a combination of this or any other chemical additive which can bind these materials together will be considered under the category of cement treated base courses. This is what IRC 37 2018 states for. Now, the important aspects, these should be these products, the material which is to be used as a base course should either be prepared by plant mixing. So, there should be a wet mix plant if I am using wet mix macadam, the unbound course wet mix macadam. So, it should be plant produced or mechanized in situ mixing process, that should be mechanized one. So, as to achieve a controlled characteristics, that is why mechanized one. And another requirement, it says that the minimum layer in case of cement treated base courses thickness should be at least 100 mm. Now, this picture shows a cement treated base course which has been constructed. Now, normally these courses may develop some finer cracks during the course of life. So, to arrest those cracks, that they do not move to the top layer. The top layers over these base courses will normally have bituminous bounded courses. So, to arrest these cracks at the level of the base courses, a crack relief layer is provided. So, it says in case of pavements with cement treated base course, a crack relief layer is provided between the bituminous layer and the cementitious base, which delays the reflection of cracks from the cement treated base layer to the bituminous layer. Now, what is this crack relief layer which is there? Normally, you can go with an aggregate layer also. A crack relief layer can be in the form of an aggregate layer, which may be of a thickness of say 100 mm, and we can use the gradation which is even recommended for wet mix macadam. So, a 100 mm aggregate layer or other gradations specified by MORTH can be used as a crack relief layer. In addition to this particular one, we even go for stress absorbing membrane interlayer. We call it as SEMI, stress absorbing membrane interlayer. So, this is another one. What is this? It is an elastomeric modified bitumen which is there, which is normally sprayed on the surface at a rate of around 10 to 12 kg per meter square, and then coated with, and then aggregate chips are applied over it, aggregate is applied over it. When this is there, when this stress absorbing membrane interlayer is there, because a high content of elastomeric modified bitumen is applied, so it arrests the cracks to move to the upper layers, and similar is the functions which is done with the help of a aggregate crack relief layer. So, these are the important considerations which are to be taken care when you are utilizing a cement treated base course in the construction of flexible pavements. Now, as per the gradation requirements, the CTB layer, cement treated base layer, should have an aggregate gradation as per the table 404, which is recommended by MORTH specifications. And here in last lecture, as we discussed, NMS, any sieve size from which some material passes. So, here you see 37.5 is your nominal maximum aggregate size. Now, there it says that the layer thickness should be at least 2.5 times of your NMS. So, this will be less than 100 mm, and that is what is recommended. If you go for a cement treated base layer, it should be having a thickness of at least minimum 100 mm. That is why it can accommodate this kind of aggregate gradation. Now, in addition to the strength perspective, when we will be looking for the characterization of materials also, we will look into those characteristics again. Just for an information, when we are, because it is a cement stabilized course, it needs to have some minimum requirement of unconfined compressive strength, and which says that the unconfined compressive strength or UCS, when it is tested as per IRC 89, which is there for the soil and granular materials stabilized using cement, lime and fly ash. This is the IRC codal specification 89, which says that the unconfined strength of cement treated base course should be 4.5 to 7 megapascal for a curing period of 7 and 28 days respectively, which was there in case of 1.5 to around 3 megapascal at 7 days of curing period when it was there for the cement treated sub base courses. So, there are specific requirements related to the strength. So, it should have gain a strength of around 4.5 at 7 days and 7 at 28 days. In addition to this particular one, since when we are designing these mixes at the laboratory scale, it is a control design. So, we always put a restriction over it that the average laboratory strength values for cement treated base course should be at least 1.5 times the required minimum. So, at laboratory, when you are designing, you should get at least a value which is 1.5 times of what you are looking there in the field, minimum values you are looking there in the field. So, this is to be again ensured, because definitely that controlled environment cannot be followed in the field. So, we want to have a factor of safety, because of which we want to have the laboratory strength at least 1.5 times of what we have in the field. Now, Advantages are there by using these cement treated base courses, because these are stronger layers, these are stiffer layers, and because of which they allow the distribution of a load over a wider area. So, this and because the strength is more, you can go with a smaller thickness of base courses compared to the thickness which is required when these are unbound courses. So, you require less materials, especially less aggregates when you are constructing the cement treated base courses. But yes, the cost is added through the incorporation of any binding material, which is your cement, lime, fly ash, that adds the cost to it, but the aggregate quantity which is required gets reduced. So, depending upon the requirements, depending upon the site specific challenges or region specific challenges or requirements of the projects in terms of the design traffic which it is going to carry, we can pick up a solution to use a cement treated base course on. So, as I mentioned, cement treated base courses have thickness typically lower than those needed for granular bases, supporting similar traffic load, as the load is spread over a larger surface area because of their higher stiffness and strength. Now, coming to the general functions of unbound courses. Now, here focus will be mainly with because nowadays very frequently we used bound courses in the base courses, like we cement treated base courses are there. So, the important unbound course in a flexible pavement structure are your sub base courses. Now, what that help particular? So, if I mention here is my compacted subgrade followed by a sub base, which is most likely to be in unbound state, which is with a granular course. Then you have a base course, and on the top you have a wearing or surface course. Now, this particular sub base course, you can see it's an open gradation which is there, this particular subgrade. What it serves the purpose is, it protects, because the wheel load is going to come and get distributed over the subgrade. So, it adds to the strength of your pavement crust. So, it protects the subgrade from overstressing. Subbase provide a strong support, and now since as you move, as I said, in the base courses you need to have a mechanized construction. So, there pavers may come up on your subbase courses to lay your base courses, which may be a cement treated or which may be a non-bounded granular courses in terms of your wet mix mechanism. So, it provides a strong support for the construction and compaction of the base courses and the upper courses of the pavement structure. The one major important function which is served by this particular layer is the drainage of surface water. This is important aspect. Whatever water which through any means we will discuss what possibilities, if it enters into the pavement structure, it has to be taken out through the pavement structure, and that one purpose is served through your unbound granular courses. So, this is one major important, and so it serves as a drainage, as a filter layer. We normally mention names as drainage layer, filter layer, separation layer. So, separation layer can be between a subbase and a subgrade, so that it separates the two materials. The fines of your subgrade should not penetrate into the coarser aggregate structure of your subbase courses. So, that can be done using a separation layer. But I want the water to move from subgrade. If there is any water which is there in subgrade which has entered because of any reason, then through capillary rise it needs to move up. So, I'll require a material which allows the movement of water, but doesn't allows the movement of the fines. So, that kind of purpose can be served through a filtration layer which allows the movement of the water. So, the water can move up to the upper granular layer, which have a more amount of voids and spaces for the movement of water. So, then if any water comes from your subgrade, goes to this particular layer and then comes out, because it gets an easy path to move out from the pavement structure. So, that particular layer which allows the movement of water will form your filtration layer, and this particular layer which is specifically designed for drainage forms your drainage layer, because it has a high permeability. So, that forms your drainage layer. So it can serves the multi-purpose purpose. It serves the purpose of, so granular cores, different type of gradations of granular cores are, that's why recommended. When we discussed in last lecture, we mentioned MORTH recommends 6 gradations for granular sub-base courses. The reason for these 6 gradations are that different gradations are used for different specific purposes. So this course also prevents the intrusion of soil grains from subgrade into the base course layered above and counteract frost actions, because if the water doesn't goes from the pavement structure, it moves through the capillary streams, it goes to the base courses, then when it goes up, it gets frozen up because of the lower temperatures on the pavement surface, and then it may lead to the damages which is related to frost and heave, or we can see freezing and thawing. Those related damages can occur because of this one. Now, so it is very important to understand the drainage of a pavement structure. One is the surface drainage and the second is the subsurface drainage. Surface drainage is easy to understand in the terms because you can visualize it, you can see how it is happening. So any surface of pavement, the rainwater comes over the surface. Now that should move out from the surface quickly. If the water should go quickly with the help of your camber or cross slope. Now for this particular one, what do? First of all, we prepare surfaces which are dense and impermeable surfaces. So whatever water falls doesn't go. We provide a camber and a cross slope so that the water falls over it. With the help of camber and cross slope, it goes to the side. So these are measures, and then it needs to be collected in some side drains and ultimately taken up to some exist facilities, which may be in terms of some culverts or any other measure for taking out this longitudinal drains water away from the pavement structure. So this is what we look from the surface point of view, that the surface drainage is there. So water can infiltrate the pavement through surface cracks, but even in this particular case there are chances that water may go down. Now this is a sealed surface, but there are chances are there. How the chances arise? In due course of time, during the life of the pavement, sub cracks may come up on the pavement surface. In addition to this particular one, you may have these earthen shoulders which may not be properly constructed. So water may enter through these earthen shoulders and may go down and can enter into your pavement structure. Water, because of the high water table, high flood level, may reach to your subgrade, and then subgrade it may rise to your pavement crust. So this is another reason which can happen, which can lead to your ingress of water. So these all, now my purpose is, one is whatever water there in the top should get moved out quickly, and whatever water which enters into my pavement structure because of any means should also be taken or removed quickly from the surface. So water can infiltrate the pavement through surface cracks, joints, shoulders. When we do the medians are constructed, when we widen the pavement, joints are comes up in that case. Even with surface drainage measures and relatively watertight surfacing, water may penetrate through cracks and accumulate at the interface of the subbase and base courses and subgrade, and it goes down and stands up at your granular courses or at your subgrade. This accumulation causes both structural damage and functional issues with these courses, because when it moves down, it carries the fines with itself. So again, there are chances that the gradation changes. When it moves down, it strips the binder from your the bounded courses, so it damages the structure integrity of your bound courses also. Internal drainage of the pavement is primarily handled by the granular sub-base course, or you provide some dedicated drainage layers. We will see how that is done. Now, what main measures which are taken up for giving these surface and subsurface drainage is, and the purpose, as I said, it is for the structure integrity and functionality of this one, and my purpose is I'll prevent the water to get ingressed into the subgrade or my granular courses during the service life. Now for this one, for the surface, the best measure is to provide a good camber and a cross slope along with a dense as well as impermeable surface. So, you can see here lot of rain is coming up, my surface is good enough. This is an exaggerated view. This slope is very high, and normally we go for a slope of 1.5 to 2% only. So, it is an impermeable surface, water falls over it, camber is given, it moves on the side. So, your surface is free, you can drive, there is no chances of skidding, it does not damages it quickly moves out of the surface. Now, again what we do for the purpose of subsurface drainage is extending the granular subbase course across the full formation width. So, here you can see if this is a cross section which is shown here. Now, this particular lower part which I am showing with the vertical lines, this is your embankment. So, you have raised it to a height, then this is what your subgrade, compacted subgrade, which normally we consider with 50 mm thickness. On the top of it, when we construct the granular subbase courses, this is the granular subbase course. This granular subbase course, here the view is somewhat more challenging to so this subbase course material have to be extended till the edges, daylighted edges. Whatever subbase course material is to be extended to the daylight edge. If I am giving a drainage layer, then the entire color which I am showing a dark layer. So, if any water which comes from the top or which comes from the bottom or which enters to the sides, when it goes to the drainage layer, it because of the cross slope and the amount of air void connectivity which it has, the high permeability which it goes to this particular layer, and with the help of the camber it comes out of your pavement structure, providing us, or this is a dedicated surface layer, or I have extended the granular subbase course, a part of it to the open edges of your crust, ensuring the formation level is sufficiently elevated. And one important aspect is, whenever you construct these new structures, you have to always ensure that you construct these structures well above the high flood level. This we already discussed in the earlier lectures. If this is not done, if adequate surface and subsurface drainage is not done, then what happens? It damages your, from the surface water damages, cracks damages your upper layers, and that if this saturation is there, it strips the binding agent, especially bitumen, from your aggregates. So, it says water in the asphalt course can lead to moisture damage, modulus reduction, loss of tensile strength, and the dry modulus of the asphalt layer can be reduced as much as of 30%. That is why it is always said that the bituminous pavements are susceptible to water, but they susceptible to water when they are not done in the proper manner. If you provide a dense impermeable surface with a good camber, there is no harm. It serves for years, it serves for very conveniently with good service life for the entire design life. Modulus, and even it says modulus reductions of up to 30% can be expected for at least asphalt treated. As a cement treated base course, I can construct some courses using another binding agent. Instead of cement, it may be asphalt. So, then there also you can get a reduction of 30%. Added moisture in unbound aggregate and base. So, when it goes to your lower layers, which is the base courses and sub base courses, a loss of stiffness of the order of 50% or more is expected. When the water goes to these granular courses, they loses their strength, and the loss of strength is up to 50%. So, see how challenging it is if you do not have a proper surface and a subsurface drainage available for you. Saturated fine grained road bed soils could experience even a modulus of reduction. Similarly, it happens up to a significant reduction of 50% in your subgrade soils also with the intrusion of the water. So, my purpose is I'll take care of the surface drainage. I need to take care in a good manner of the subsurface drainage. One example, now I can give you in a better manner. It says, okay, you have this is your subgrade. Over the top, you construct this particular one as a layer which is mentioned here as a filter layer. So, this separates out your subgrade from your drainage layer, and on the top of it, this is your drainage layer. This vertical line is your drainage layer. The bottommost is your subgrade. So I'm giving a filter layer here. This filter layer separates my drainage layer from the subgrade, doesn't allows any intrusion of fines from my subgrade to the drainage layer, but allows the flow of water. So it has a permeability but low as compared to your drainage layer. So this water from the subgrade will pass through, if any enters, will go through capillary rise through this filter layer and will come up to this drainage layer, and now this drainage layer is exposed to the edges. Now here you can see they are extended to the entire formation width. Formation width includes your carriageway and the shoulders also. So even for the other shoulders also, the granular courses are extended. Now at these edges, normally it is said that if these edges are kept as unbound materials, then there are chances of failure of these edges. So that's why it says and 0.5 meter should be stabilized with some 2.5% emulsion or 2% cement. So this small width needs to be stabilized so that the edges doesn't get disturbed. Otherwise, when they are open, they gets disturbed because of the side slopes. Now here again you can see this is what it mentions, that you have a shoulder, this is your, on the bottom of this shoulder you have your sub-base courses, again whatever material is there, and this is your open graded sub-base courses. So you have this perforated pipe. I will show you in this particular example, in this particular figure. You can see if it's some slope is there, some side slopes are there, one pavement is constructed on this particular edge. So what I am doing here, I have provided a side drains. These are my longitudinal drains which are provided. Now this is this is a water table. My pavement crust should be high enough with respect to the water table. And then what I am doing, I am extending, this is my drainage layer, I am extending my drainage layer here. This is the bottom layer which is there, which is my filter layer. Now here in this longitudinal drains, I am putting up a drainage material which can be an aggregate with a particular gradation, and then there may be a use of some geosynthetic liner also. I will show you in the upcoming slides, and then there is a perforated pipe is there. So whatever water which comes from here goes into this aggregate one, and it comes through in this particular perforated pipe which will have a slope. So it will go through perforated pipes and will be taken out from the pavement structure at some culverts or drainage outlet facilities which will be created. So this is one way of doing it. Now what type of drainage layer is there? What is drainage layer? It's a particular kind of aggregate gradation which we take, and that makes that layer capable of draining the water quickly out of it. So MORTN says that, as well as IRC 37 says that grading 6th of our MORTN table is, which comes under the granular sub-base course, is good enough to drain the water out of it. So they recommend, like MORTN says, grading 5 and 6 are recommended for sub-base cum drainage layer. The GSB gradations 1, 2nd, 5th and 6th are recommended for filter cum separation layer. And one important aspect it says, normally when your pavement crust is not thick enough, or you don't have that much high amount of design traffic, and your total sub-base course thickness comes out to be 150 mm only, then you can't provide two layers, which one acting as a filtration layer and second acting as a drainage layer. So you have to come up with one single layer which has to serve both the purpose of filter cum drainage layer. So that is why it says the minimum thickness of the single filter cum drainage layer should be 150 mm for the functional requirement. So, and it says that for such cases a single drainage cum filter layer with GSB gradations of 5 and 6 can be provided. And which gradation? Again you have to look upon the NMS of it. As I said, the layer thickness should be 2.5 times of the NMS of it. So you need to pick up the gradation 5th or 6th if only a filter cum drainage layer has to be provided. And if a drainage layer can be one as a filter layer, one as a drainage layer, normally 2 layers, then the bottom one is your filter layer, upper one will be your drainage layer, and you can pick up the grade 6th for use as a drainage layer. Now, some additional features which we make during providing these drainage, you can see this is a longitudinal subsurface drain which is there, a cross section of a longitudinal subsurface drain. Here you can see this particular one, there is a geosynthetic fabric which is overlapped at the top. Now, what the purpose of it is, any fines should not get trapped into or reduce. If it goes inside it, it will reduce the drainage capability of your gradation which is used here. So, this is the graded crushed aggregates which are used here, they follow a specific gradation because they need to have a high permeability, and then the water gets collected into these perforated pipes. So, their designs are also given as per IRC guidelines. It says IRC SP 42 is to be followed for. So, here this can be a geosynthetic, a geofilter can be, a synthetic geofilter can be there which prevents any intrusion of fines into this aggregate gradation, and here outside we can put a coarse sand bed also. Now, this, and on the top you have the compacted soil. Now, this will give whatever your the drains which will be there, the subsurface drainage layer should be connected to this particular one. Anything which is coming to this particular one, this will serve your purpose throughout the service life. So, the chances of getting clogged is very less. Now, here you can see the another feature of this particular one, this is your drainage layer. Now, how this is constructed, you can see this is the drainage layer where you can see it is again this particular one is a synthetic geofilter layer which you can put. This is the same gradation what you have for the drainage layer. You have the perforated pipes, this is the crushed aggregate because the drainage layer same material can be used in this particular one, and this is the perforated pipes, perforations are shown there. Now, it moves in longitudinal direction. So, then at certain locations you have to take out this water. So, again unperforated pipes are there which are constructed to take out the water. So, either you have cross drainage structures. So, this longitudinal drain goes, and at some cross drainage structures which can be culverts, there the water gets moved out of this particular one. Now, unfortunately, in some cases where these the provisions of subsurface drainage is not taken care, then it becomes a big problem. Water enters from the top, cracks or sides, and it gets accumulated into your these granular courses or your subgrade and reduces your strength significantly. So, it leads to the formation of ruts, it leads to the stripping. So, we need to, but it is already constructed. So, some measures can be taken up in those cases also, so as to improve the subsurface drainage. One is provision which is shown here. If this is an already constructed structure, this is the direction. If this is the vertical gradient is in this direction, I can provide a side aggregate drain. I will call it as an aggregate drain. So, I am providing aggregate drains here, I am providing aggregate drains here. So, I have to construct in my earthen shoulders, I have to construct these aggregate drains. So, whatever water which is there, if it comes to these aggregate drains and moves out through these lateral drains in that case. So, I am having, and the thickness of this particular one is normally 300 mm. So, these aggregate, and they have, and we have the IRC SP 42 have defined what type of gradations you can use. This is another one where only these drains, the cross drains in the shoulders are shown. These are aggregate drains. So, this goes in this particular manner. So, these are features once you have already constructed a pavement structure and the subsurface drainage is not good enough, then these provisions of aggregate drains which have specific gradations, and the purpose of these specific gradations is to give a good permeability. Normally, a drainage layer is expected to have a permeability of around 300 meter per day. So, a good drainage capability is to be required. That is why this aggregate gradation is to be very important to be followed in the field. Now, in addition to this particular one, sometimes nowadays with more advancement, especially in geosynthetics, we make use of geosynthetics to achieve a better drainage, filtration as well as separation. An example of this can be seen in this particular manner. Here this is in lieu of aggregate drainage layer, geosynthetic drainage composite. What that drainage composite is there? We have on a top a geosynthetic which allows the water to move but does not allow the fines. So, it serves as a filter layer. We have a geosynthetic at the bottom also. So, geotextile at the bottom also, geotextile, and in the middle of it we have a geonet. Geonet is a 3-dimensional structure. This is an example of it. It has a very high drainage. So, the water, so it does not allow any fines to get trapped inside it. Water will come into it, and through this geonet it will come out of your pavement structure. So, now in addition to the drainage, it serves the purpose of your filtration, separation, and it adds to the reinforcement of your structure also. So, this is another additional advantage. So, it says in lieu of aggregate drainage layer, geosynthetic drainage composites, where geonet between two geosynthetic layers can be provided, and this can be, so here you are having a very controlled environment, because in gradation the gradation has to be continuously monitored, but yes, it will add to the cost definitely, but the amount of improvement or the amount of improvement in the subsurface drainage is obtained to secure the life and performance of the pavement is very good. So, it serves the purpose of separator and filter, and the IRC SP 42 states what how that is to be installed. So, nowadays geosynthetics are also, or the combination of geosynthetics to serve as the purpose of your filtration, drainage and separation layer is also becoming popular. So, with this particular one we complete this particular lecture. Thank you all of you.